Welcome to the deep dive. Today, we're really cutting through the noise. We want to understand how businesses can leverage these powerful statistical models.
Right. To predict key outcomes, make smarter decisions.
Exactly. We've got your sources here, all about supervised learning and linear regression, our mission. Extract the absolute most valuable insights for you, fast.
Yeah, it's about moving beyond just, looking at numbers. It's about uncovering those hidden connections in the data.
Like X-ray vision?
Kind of. Think of it like that, yeah.
Okay.
X-ray vision for your business. So you can see not just what happened, but why it happened and, well, maybe what happens next.
Turning data into actual intelligence.
Actionable intelligence. That's the goal.
Okay. So if you're curious how companies forecast sales or maybe optimize their marketing spend, or you just want to decode a complex data set without, feeling totally overwhelmed, you are definitely in the right place. Let's unpack these sources, see what crucial lessons they hold. Okay, so before we jump into predicting the future, we need to grasp the basic idea, right? How different pieces of information relate to each other.
Yeah, the fundamentals.
And the sources, they start right there.
Right.
Talking about the association between two variables.
Indeed. We're talking about concepts like covariance and the correlation coefficient, the R value.
Ah, yes.
Like our quick compass, basically. Points to the direction, the strength of a linear relationship. From +1, strong positive.
Down to -1, strong negative.
Exactly. And 0 means, well, weak or maybe no linear connection.
And here's, I think, the most crucial takeaway early on. We really can't overstate this one.
Go on.
Correlation is not causation.
Absolutely fundamental. Cannot say it enough.
So if a company sees its ice cream sales shoot up when the temperature rises, sure, strong positive correlation.
Makes sense.
But those ice cream sales, they aren't causing the temperature to go up.
No, definitely not. It's a classic business trap, isn't it? Yeah. Confusing that association with direct influence.
It really is.
And being able to distinguish between just observing a relationship and understanding if there's a true causal influence.
Yeah.
Well, that's the foundation.
For building a reliable model.
A model that actually drives results, yeah.
Yeah.
Which brings us to the idea of a model itself. George Box, famous statistician, he said, all models are wrong.
But some are useful. I love that quote.
Me too. It's spot on.
It reminds me of a subway map, It's not the actual city.
Not street by street, no.
But it's incredibly useful for getting around understanding the structure. So for a business, what does it really mean to model data?
Well, when we model data, we're essentially defining how a dependent variable, Y.
The outcome we care about, like sales.
Exactly. Sales, customer churn, whatever it is.
Yeah.
How that's related to one or more independent variables, X.
The factors we think explain or influence Y, like ad spend, maybe?
Ad spend, product features, customer ratings, yeah. We're trying to build a sort of mathematical representation of that connection.
Okay, so we build these mathematical things. What's the goal? Is it always just about forecasting? Predicting the future?
It's often about that, but not only that, it's kind of twofold. The goals are prediction and explanation.
Okay.
Prediction is, well, using our X variables to forecast Y. Like you said, predicting next quarter sales based on current marketing.
Makes sense.
Explanation, though, that helps us understand why things happen. It quantifies the impact of one variable on another.
Ah, okay.
And crucially, with explanation, we really want to isolate that impact. Ideally, control for other factors that might be muddying the waters.
We've talked about models, but how do we actually, build these predictive engines?
Good question.
That's where machine learning comes in, right? With supervised and unsupervised learning.
That's right. Two primary paths.
So what's the quick way to tell them apart? The mental model.
The key distinction, really, is whether your historical data has a known outcome. Labels.
Labels.
So in supervised learning, you've got this rich history where you already know the outcome. You have the answer key, basically.
Yeah.
And you're teaching the model to recognize the patterns that led to those known results. It's like training a highly specialized algorithm to find signals in past performance.
So if I'm trying to forecast next month's sales and I have all this past sales data, I'm automatically in the supervised camp.
Exactly. Because you have the past sales figures. Those are your labels.
Right.
Or if you're detecting fraud using past labeled fraudulent transactions, or estimating demand based on historical demand figures,
Yeah.
all supervised, You have the answer from the past.
Okay, and unsupervised.
Unsupervised learning, well, that explores unlabeled data. You're looking for hidden patterns, inherent structures.
Like a detective.
Yeah, like a detective searching for clues without maybe knowing the specific crime yet. Grouping customers into segments based on behavior, finding anomalies, that kind of thing. No predefined answers.
Got it. So for our goal today, predicting sales, we're firmly in supervised learning. And within that, our sources zoom in on regression. What exactly is regression at its heart?
Regression is a statistical method. It's designed specifically to model the relationship between a numerical outcome or dependent variable.
Like sales figures.
Yes, exactly. And one or more explanatory variables. The business applications are, well, they're incredibly diverse.
I bet.
Forecasting stock prices, housing values, evaluating the actual tangible impact of marketing campaigns.
Or even like how product features drive user engagement.
Precisely. All that falls under regression.
And there are different types of linear regression you mentioned because, well, relationships aren't always simple.
No, they're not. So yeah, we'll focus mainly on two forms today. Simple linear regression, just one independent variable, and multiple linear regression, which lets us use two or more.
Okay, to really bring this to life, the sources use this great example. A simulated tech company's data.
Yeah, I like that example.
They've got variables like advertising spend, product complexity, customer support rating, and of course, sales. Sales is our Y, our dependent variable.
Right. And their first step is building a simple linear regression model.
Yeah.
Just looking at advertising spend and how it influences sales.
Trying to quantify that link.
Exactly. Figure out its significance.
And the initial insight, pretty compelling. Advertising spend has a statistically significant positive impact on sales.
Which you might expect, but it's good to quantify it.
Totally. And listen to this number. For every extra $1,000 spent on advertising, sales are predicted to go up by about $930.
Wow. That's a strong connection. Almost one-to-one return on that metric alone in this model.
Yeah. And the model, its R-squared value it explained 73.66% of the variability in sales.
Which is substantial for a single predictor. That's a really good starting point for any business.
Definitely.
However, and this is a big however, for any regression model to be genuinely reliable and for its interpretations to be trustworthy, we need to ensure it meets certain assumptions.
Okay. The fine print.
Sort of. We won't get totally lost in the statistical weeds today, but remember, things like linearity assuming a straight line relationship.
Right.
And consistent error variance, homoscedasticity is the fancy term.
Right. Okay.
Those are pretty crucial. Violating these assumptions can completely skew your insights.
Leading to bad decisions.
Exactly. Incorrect business decisions.
And the sources even mention visual checks, which I find really helpful, like residuals versus fitted plots.
Yes. Those plots are key diagnostics.
They point out, for example, a slightly curved trend in one plot, which hints that maybe linearity isn't perfectly met.
It could suggest that, yeah. Or it might highlight specific data points, outliers, that need a closer look.
These aren't just like academic exercises then. They matter in practice.
Oh, absolutely. Not at all academic. These diagnostic checks are crucial. Ignoring them, it means you might be building your strategy on, frankly, a shaky foundation.
Right.
For a business, it's about knowing if your model truly reflects reality or if it's giving you a distorted picture. Those outliers, for instance, they could be errors or unusual events or maybe a really unique situation you need to understand separately.
But even a good, simple linear regression, it still has limits, doesn't it? The sources make that clear.
Absolutely clear. Its biggest limitation. It only includes one predictor, just one X variable.
And real life isn't usually that simple.
Almost never. Real-world business outcomes are almost always influenced by multiple factors, all working together, sometimes pulling in different directions.
So what happens then?
Well, this leads to what statisticians call omitted variable bias.
Omitted variable bias.
Yeah.
Whoa.
When you leave out important predictors, it can give you a really misleading picture of the impact of the variable you did include.
Oh, so.
It can make that single variable look more important than it is, or even less important, or sometimes just completely wrong about the direction of the effect, because it's implicitly soaking up the effects of other things it happens to be correlated with.
Okay, so this means businesses could end up putting money in the wrong places if they're only looking at one factor.
Easily done.
But what happens when your business problem is more complex? Which, let's face it, is most of the time. Real-world scenarios are rarely that simple. So that's where we need a bigger toolkit, right? Enter multiple linear regression.
Precisely. Multiple regression is all about getting a more complete, more nuanced, and frankly, more accurate picture.
How does it do that?
It lets us incorporate several independent variables, multiple x's, all at the same time. This gives a much more realistic explanation of the dependent variable, the y,
Okay.
and that fundamentally improves prediction accuracy. But crucially, it helps minimize that omitted variable bias we just talked about.
So you get a clearer view of each factor's unique contribution.
That's the idea. You can see what each variable is doing, holding the others constant.
And this is where it really kind of flexes its muscles, right? Untangling cause and effect.
Yes. In a way, simple models just can't. Imagine trying to understand the true impact of, say, education on someone's income.
Okay.
Your first thought might be, okay, more education, more income. But then you immediately think,
Oh, wait, what about intelligence? Or maybe family background or work ethic?
exactly. Those are potential omitted variables or confounders. Multiple regression lets us try to control for those things.
Control for them. What does that mean practically?
Well, when we talk about the effect of education on income controlling, for IQ, for example, we're essentially asking, what's the change in income for one more year of education, assuming IQ stays the same?
Okay. You're isolating the education effect.
Trying to, yes. It helps us avoid those, the rooster crowed, therefore the sun rose type of faulty conclusions. You separate the unique influence of each variable as best you can.
Makes sense. So how does this more sophisticated approach look with our tech company sales example? How did they build on that simple ad spend model?
Right. So in the sources example, they expanded the model. They included advertising spend, product complexity, and customer support rating all together to predict sales.
Okay. Bringing in more factors.
Exactly. Gives us a much richer, multidimensional view of what's really driving revenue for this hypothetical company.
And the insights, are they more detailed?
Incredibly detailed and very actionable. Check this out. For every $1,000 increase in advertising spend, sales are predicted to increase by $930, holding the other variables constant.
Okay, that holding constant part is key.
It's absolutely critical. Then interestingly, a 1-unit increase in product complexity, that's associated with a $620 decrease in sales.
Oh, so maybe simpler designs are better for this company's product?
It suggests that, yeah. At least when considering ad spend and support rating too. And then a 1-point increase in the customer support rating, that correlates with a significant $1,270 increase in sales.
Wow, customer support really packs a punch here.
It seems to in this model. And importantly, all three predictors, ads, complexity, support, were highly statistically significant, meaning we can be pretty confident these aren't just random blips in the data.
Right.
And this more comprehensive model, it explained an even higher chunk of the sales variability, 77.8% R-squared.
That's a decent jump from the simple model's 73.66%.
It is. It shows we're getting a better handle on what drives sales. It gives businesses much more granular, actionable insights.
So connecting this to the bigger picture.
It means they can clearly see the combined effects and the individual effects of marketing, product design, customer service, all on the bottom line. It's not just one thing. It's like a symphony of factors.
And this model helps us read the score.
Yeah, it helps us understand the score. Nicely put.
Okay, now for the moment of truth. The head-to-head comparison. How do these two models, simple versus multiple regression, really stack up when we look at their performance metrics?
Right. The sources laid this out really clearly using standard metrics. Things like R-squared, adjusted R-squared, which accounts for the number of predictors.
Mm-hmm.
And then error metrics like residual standard error, RSE, mean absolute error, MAE, and root mean squared error, RMSE.
Okay, remind us quickly what those error ones mean.
Low is better. Right. Exactly. Lower is better for all the error metrics. RSE is like the typical prediction error in the original unit, say dollars of sales. MAE is the average absolute size of the errors. RMSE is similar, but it penalizes bigger errors more heavily.
Got it. So what did the numbers show?
The results are pretty decisive.
Yeah.
The multiple regression model consistently outperformed the simple one.
Across the board.
Yep, R-squared, simple was 73.66%, multiple hit 77.8%. So multiple explains more variability. Adjusted R-squared, simple 0.735, multiple 0.776. Still better for multiple even after adjusting for complexity. RSE, simple was 8.12, multiple dropped to 7.76. Lower error, more precise predictions for multiple. MAE, simple 6.43, multiple down to 6.07.
Yeah.
Less average error, again, RMSE. Simple 8.1, multiple 7.73. less variability in the errors penalizing large ones.
Okay, so the numbers really don't lie here. The multiple regression model clearly gives you improved precision, better accuracy. It's just a demonstrably better tool for this kind of analysis.
Absolutely. And the key advantages, they're profound, really. It captures those
Yeah.
more complex real-world relationships much better. It gives you improved precision in your predictions. It effectively addresses that tricky, omitted variable bias.
Which we saw can be really misleading.
Totally. And maybe most importantly, it generates truly actionable insights for businesses.
How so?
Well, instead of just knowing if advertising works, you know how much it works, roughly, and how that effect plays out in conjunction with things like your product complexity and the quality of your customer support.
It's like moving from a black and white snapshot to like a full color, high def video of your business operations.
That's a great analogy.
Yeah. And this means a business can pinpoint specific areas for improvement. Like, okay, enhancing customer support seems to have a really strong, tangible impact on sales, even when we account for ad spend.
Exactly. You can quantify it. The sources even spell out a practical implication if you rely only on the simple model looking at ad spend. You could be ignoring other critical factors like product features or customer satisfaction, and that could lead to less effective strategies, maybe even wasted resources on just one lever when others matter more or interact.
Makes total sense.
And of course, you can use these models to predict. With the simple model, okay, ad spend is $60,000, you get one sales prediction.
Right.
But with the multiple model, if ad spend is $60K and product complexity is, say, 7 and support rating is 4, you get a much more nuanced and likely more accurate prediction of your expected monthly revenue.
It's like having a clearer crystal ball.
A more complete crystal ball, yeah. Allows for more proactive, data-driven planning.
So what does this all mean for you, for your business?
Well, the bottom line is, embracing multiple regression lets you integrate key factors for more accurate predictions, deeper explanations.
Which leads to truly informed, effective decision-making.
It moves you from guessing to knowing, or at least to making much more educated guesses.
Wow. Okay, what a deep dive that was into linear regression.
We covered a lot of ground.
We really did. From just the basic idea of correlation to understanding what makes a model useful, all the way to seeing how simple and then multiple regression models give you this incredible power to predict and explain outcomes.
Yeah, it's a lot to take in maybe, but the value, I think, is undeniable.
Definitely.
We've really tried to hammer home that correlation doesn't mean causation,
Super important.
that multiple regression generally offers better insight because it controls for those extra variables,
Right.
and that checking those model assumptions, that's essential if you want reliable results.
It all comes back to making better business decisions.
Exactly. Moving from gut feelings to, well, data-driven understanding.
So for you, our listener, this deep dive really shows how powerful data analysis can be. Imagine applying these principles in your own field.
Yeah.
Dissecting complex problems with these tools. They're sophisticated, sure, but also quite accessible once you grasp the basics. It's about getting a clearer lens to view the world.
And maybe
Yeah.
this raises an important question for you to think about.
Right.
How might understanding these regression concepts change the way you interpret, say, news headlines or business reports, especially those that claim one specific factor is solely responsible for some outcome?
Ah, good point. Will you start looking for those potential omitted variables?
Exactly. The things that might be telling a different, maybe more complete story lurking beneath the surface.
Something to think about. We've really just scratched the surface today of how data can unlock insights.
Just the beginning.
But hopefully you now have a much clearer understanding of this really powerful approach. Until next time, keep diving deep.